This is a video of me going through the domain and range for the functions on 1.3e. Okay, so if we start with a of x, let's do the denominator let's do rather the domain first. And in this case, the only thing we have to worry about is we can't have the denominator be 0. So this means that 3 minus x plus 2 squared cannot be 0. So 3 cannot be x plus 2 squared. So x plus 2 cannot be plus or minus root 3, or in other words, x cannot be negative 2 plus or minus root 3. So there's two values it can't be for the domain. So writing that, I've got domain negative infinity to negative 2 minus root 3, union negative 2 minus root 3 to negative 2 plus root 3. Oops. Union negative 2 plus root 3 to infinity. Okay, so that's the domain. And now for the range. I'm noticing there is a limitation for the range. I'm just going to leave a space and do the work below. Because the denominator, so here's what I've got. I've got negative 4 over, actually I'm going to move this over so I have a little bit more room. Okay, I have negative 4 over 3 minus, well, something squared. The smallest coming out of that is 0. So I'm going to write that x plus 2 squared can just go from 0 to infinity. So 3 minus that gives me negative infinity, because 3 minus infinity will go towards negative infinity. And 3 minus 0 is 3. But I'm just going to sneak in there the fact that it also can't be 0, just so I don't forget that. Again, the denominator, if it was just by itself, I would say negative infinity to 3, but I know I can't divide by 0, so I'm going to add that extra piece in there. Okay, so remember at this point, it's very important to consider all the extremes. Is it going to go towards negative infinity, 0 from the negative side, 0 from the positive, and positive infinity? All right, so let's start. If I have negative 4 over negative huge, that's going to go towards 0 from the positive side. So I've got because a negative over a negative is going to be positive. So I am going to hit 0 from the positive side. Then negative 4 over a tiny negative, because they're both negative, it's going to end up being positive, but a negative 4 over a tiny negative is going to get me towards a huge positive. So it looks like I'm going to achieve everything from the positive side. Now from the negative side, the way I would get towards negative infinity, since the numerator is negative, it would have to be negative 4 divided by a tiny positive, which I actually do have here. So, because I've got, really close to 0 in the denominator. So I will go towards negative infinity. The only way I go towards 0 from the negative side would be negative 4 over infinity, because that would bring it really close to 0. But I don't have that. I only have the biggest it goes in the denominators to 3. So negative 4/3. So that's where my limitation comes in. So the range of this function then, excuse me, is negative infinity to negative 4/3 union 0 to infinity. Okay, so yeah, having something to an even power for the variable of an even power in the denominator is going to limit things. All right, let's look at this second one here. B of x. So B of x, the difference here is the denominator, the variable component is raised to an odd power, not an even. So let's first do the domain like we did before. The denominator cannot be 0. So 3 cannot be x plus 2 cubed, or x plus 2 cannot be the cube root of 3. And notice there's no plus or minus. When you take an odd root, it's just, if it were negative, it's negative. If it's positive, it's positive. So I do not have the plus or minus situation. So x just cannot be negative 2 plus the cube root of 3. So the domain would just be negative infinity to negative 2 plus the cube root of 3 union negative 2 plus the cube root of 3 to infinity. So it just can't be that one value. As for the range, well, unlike, switch colors here, unlike before, where we had a limitation on the variable component, here the range of something odd is everything. So I've got 3 minus negative infinity to infinity in the denominator. Well, that's still going to be negative infinity to infinity when I incorporate the 3 minus. However, I just want to remind myself that I can't divide by 0. So turns out that this here fraction achieves everything. There's no limitation here. It achieves everything except 0, because the only way a fraction can be 0 is if the numerator is 0. And of course, that's not the case here. So the range here is much less limited than the one in part A. So negative infinity to 0, union 0 to infinity. Okay, so now let's look at C of x. So for C of x, few things when I think about the domain here. I know that the denominator can't be 0, and I can't take a square root of a negative. So a lot of things going on. So 2 minus square root of 4 minus x cannot be 0, and I need 4 minus x to be greater than or equal to 0. So let's do that one. X has to be less than or equal to 4. And when would 2 minus 4 minus x equal 0? Well, let's see. Square both sides. So I've got 4 cannot equal 4 minus x. So x cannot be 0. Okay, so those are the two things that are impacting my domain. Has to be less than or equal to 4 and can't be 0. So my domain then is going to be negative infinity to 0, union 0 to 4 with a bracket. All right, so now for the range, and there is a limitation in the denominator. So I'm going to have 5 over 2 minus, well, what's the range of square root of 4 minus x? Well, the smallest coming out of that will be 0, and the biggest will be huge. So 0 to infinity. All right, so then I've got, incorporating the 2 minus, I've got 5 over negative infinity to 2, but it can't be 0, so can't divide by 0, so I'm going to throw that in there too. So now this becomes super similar to part A, and except for the fact that now it makes it a little easier that the numerator is positive. So again, versus negative in part A. Again, we're going to consider all the extremes here. Okay, 5 over negative huge is going to get really close to 0 from the negative side. And 5 over tiny negatives, which I have here, is going to approach negative infinity. From the positive side, I do have 5 over tiny positives, which is going to go towards positive infinity. But the closest, I don't have positive infinity in the denominator, so the closest I'm going to get to 0 from the positive side is going to be 5 halves. So that there is my range. All right, now let's look at d of x. So for d of x, the domain, the only thing I have to worry about is the denominator cannot be 0, or x plus 4 squared cannot be negative 6. Well, something squared is never going to be negative, so that can't happen. So it's always, the denominator is never going to be 0. So that means the domain is everything. There's no restriction there. I'll never get 0 in the bottom. All right, the range, however, I've got 3. The squared piece, like we said before, ranges from 0 to infinity, and then I've got plus 6. So in the denominator, I'm going to have it ranging from 6 to infinity. Okay, so clearly coming out of this is only going to be positives. So the question is, am I going to get really close to 0, and am I going to explode towards infinity? To get close to 0, I'd have to have 3 over a huge positive, which I do. So it's going to get really close to 0. To explode towards infinity, though, it'd have to be 3 over a tiny positive, and I don't have that. In fact, the smallest I have here is 6. So 3, 6, or I can reduce that, 1/2 would be the biggest there. So not a big range. All right, last one. Let's look at this one here, kind of similar to C. So E of x, so again, let's deal with the denominator. First thing that I notice is I can't have a denominator 0, but I also have a square root. Oops, this is plus 3. I also need x, so I need x plus 3 to be greater than or equal to 0, or x greater than or equal to -3. All right, so let's see when it equals 0, because I can't have that. So square root of x plus 3 cannot be 2. X plus 3 cannot be 4, so x can't be 1. All right, so putting this together, my domain would be -3, can't be 1, to infinity. All right, now for the range. For the range here, I've got -1 on top. The square root of x plus 3, the smallest coming out of that would be 0. The biggest would be huge. And then I've got -2. All right, so that means I have -1. And then I'd have -2 to infinity. However, just like we did before, I can't divide by 0. So I'm just going to put that in. Can't be 0. And this also helps me when I check my extremes. So again, the extremes we're always going to check. All right, so I've got a negative in top. So to check negative infinity and 0 from the negative side, I'd be dividing by positive. So let's do that. So in order to go towards negative infinity, it would have to be -1 over a tiny positive, which I do have here. So it'll go towards negative infinity. To go from 0 to go towards 0 from the negative side, I'd have to have -1 over a huge positive, which I do have, because in the denominator, all the positives get covered. Okay, now on the positive side, in order to go towards 0, I'd have to have -1 over a huge negative, and that's where I'm limited. The biggest negative I have in the denominator is -2, so the closest I'm going to get to 0 from that positive side is 1/2. Now, to go towards positive infinity, I'd have to have -1 divided by a tiny negative, which I do have here. I've got that right here. So it will explode towards infinity. There you have it.